So, hi everybody. As you can see here, my name's Anirudh. Normally people call me Ani. Tonight I'm going to be doing a lightning quick introduction to a dependency injection framework which we use in Android and Java called Dagger 2. So sort of starting off where everyone starts, who the hell am I? Not Jackie Chan. I wish I was. My brain is kind of weird. I thought about me, who am I? Jackie Chan, who am I? That's okay. Right now, I am currently working as an Android developer for a certain red-colored bank. I've been a meetup organizer for, I think, about 2 years, so you may have seen me around. I've been developing on Java since 2009, basically through uni, and I've been developing on Android for at least 4 years now. So I've been around the block for a while, and that's my email, Twitter, if GitHub. It's kind of a tumbling weed kind of a thing, but if you need to get in contact with me or if you have any questions later on, you can grab me by those. So, jumping straight into it, what the heck is Dagger? I'm just going to put some copy pasta up here right now. So Dagger is a fully static compile time dependency injection framework. It's available for Java as well as Android. It's the first to actually do its whole stack in a code generation way. So let's get a bit more into that in a bit. And it was originally created by Square Open Source, which does a lot of really cool libraries on Android, but now it's officially supported by Google. That was kind of a bit of copy pasta, but I think this statement from Jake Wharton, he's a really good developer. He's been working with the Android project for a while in Square, and I think this sort of sums up Dagger sort of in a nutshell. So Dagger does basically all the code generation and wire up that you do by hand. And I've got an image of the quote there, but you can actually see the Reddit thread where Jake actually answered that. So if you were to, it would take the approach where, if you were to write all your dependency injection by hand, it would automate that for you. Yeah. Sort of getting into why you would want to use Dagger, there's a sort of bunch of pluses and negatives for it. First of all, because it is code generation and compile time, the build is most likely to fail. There is a few caveats around that. It's mainly that if you configure Dagger wrong, it's going to fail. If you have an issue, you're probably going to see it in your build logs, and it will pop up, and it's quite obvious to see. Because it does take a code generation approach, performance does matter, so it actually is very fast, since all your code is generated there for you. It's no reflection. It's debuggable, traceable, pro-guardable, actually, if anyone uses that. It uses JSR annotations sort of where possible, and you can actually do some really cool stuff with custom annotations which you define yourself for scoping. And also, it's really good in frameworks where you have fixed constructors with certain parameters, especially like Android. So in Android, we have activities, fragments, views. They have default constructors or certain fixed parameters, which is all you're allowed to use. And this helps you get around that by having something that is sort of away from it. Some of the negatives, it has a bit of a learning curve. I started dealing with Dagger about 6 months ago with my current job. It took me about a month to sort of figure it out, and I'm still sort of learning with it. It does deal with generated code since it is compile time, but I don't know, you can call that a negative or a positive. It's up to you. Some people call it less flexible and less dynamic, but it's sort of arguable, and it relies on strong types. And one more catch is that you actually have to fix your injected method visibility because of how it works. So let's just go through some of the alternatives in Java land. So I think everyone's probably, if you've used dependency injection, you've used one of these. There's Spring DI. There's Google Juice, Pico Container, as well as Java 6 CDI. And that's sort of all that came to mind. It's full of beans. While I'm here, so who's used one of these frameworks? Maybe put your hand up. What's the most popular? So let's just go through maybe Spring, quite a lot of us, Juice, and I'm not going to ask about the last two because they're probably less popular. There's also some alternatives in Android land. There's a lot of frameworks around this, but I'll have a look at a couple of the more popular ones. So we have Android Annotations. It's a sort of write less, do more framework. It does do compile time generation, so it is similar to Dagger, and it basically deals with all your boilerplate. One thing you'll notice is that it does a bit more. So it does view and resource injection, as well as threading, event binding, and a bunch of other things. And because it is code generation like Dagger, you have a lot less performance overhead, so performance is a lot better. What you'll also notice with Android Annotations is that because it does do generated classes, it's kind of ugly to deal with. And when it comes to dependency injection, you're dealing with more beans. It's not fun. There's also RoboJuice. So this is essentially Google's Juice project for Android. It takes a similar approach where it's runtime reflection, and for the dependency injection, it does do some similar stuff to Android Annotations. So it does view and resource injection, and yeah, it does hit that runtime performance overhead. But one of the really cool things about these two frameworks is you can actually use these two together, and you can sort of leverage each of the benefits and negatives. You can leverage the benefits of each of the frameworks to sort of compensate for each other. Just saying this straight up front, Dagger does not deal with any of the view injection stuff. It is just pure DI. Do you have a question?
Can you expand on time performance overhead? Is it significant?
Yes, especially on Android. You don't want to do things at runtime if possible. So if you want to do reflection, you're going to have to look up everything, and it's going to sort of hurt your performance, especially if you're doing a lot of DI. So with frameworks more like Android, especially because these are there, it's better to have a more performant application. So you really try and cut down where possible. Just as a sort of bonus, if you do want to use view injection libraries, there's a couple alternatives. So there's Butterknife, which Jake Wharton has written, and he's got a Kotlin variant if you're really interested in that, called Kotterknife. And something which I perhaps neglected to mention, but I will now, is Dagger 1. It's the original project, which was written by Square, and if you have a look through the issue tracker, you'll notice that it sort of says, yeah, we'll deal with the issues in Dagger 2, and there's a bunch of notes. You can grab it when I actually post these up. Yeah, so let's get right into some sort of code. If you want to set it up, you really need to do two things with Gradle. So in your root Gradle file, you just chuck in a annotation processing tools library. So we just happen to be using Neen Bidank's apt plugin, and with your modules build Gradle file, you just add these dependencies as well as applying the apt plugin so it actually picks up and uses it. And also for the Maven users out there, you can use it. I haven't tried it out. I've mainly been working on Android projects, so I'll focus in that context, but it seems to work. So I had a bit of a quandary when it came to sort of code examples. On the Dagger website, they do a coffee machine. It's a bit complicated to understand, and it's not very friendly. And as much as I love coffee, especially in the morning when I've been programming until midnight, I have no idea what thermosiphons are, so nope. Not going to happen. Instead, I'm going to do two code examples, one where I break things and one where I don't. And this is actually an Android example. The first one is the MyDagger example. It's a very dumb project, but it will sort of show what happens when you do things wrong and when you comment things out, which you really shouldn't. I did a couple iterations on the other examples. I was thinking, let's build a robot, let's do all the parts and modules for it, and let's use that as an example, and I didn't like it. I tried let's build a computer, and I didn't like it. And last night, I spent about 2 hours whipping up the example which I'm going to show tonight, which is the Meetup raffle application, which we'll be using later tonight to pick out the raffle winner for tonight. Just as a caveat, I only spent about 2 hours on it last night. It has zero reflection on how I normally would develop an Android application, so it is very error prone. There is zero error handling in it, and Hopefully you won't look too deep into the code, but I'll make it available on GitHub and enhance it over time. So let's get straight into it, I guess. So I've actually got my Dagger example, and if I can find presentation mode. It's a very basic project. I'm actually using Android Studio 2 because I'm an Android developer. This is the beta version, so it's actually quite stable now. And if I go to the right one, I've got a bunch of to-dos which will show you what happens when you sort of break things. So first off, I'll just show you the apps build Gradle file and the actual root Gradle file. So we have the dependencies in there. So that's the the annotation processing tools plugin, and you have all your Dagger dependencies right here, as well as the apt plugin. So probably a bit more about the anatomy of Dagger. You have something called a module, which defines sort of all your nodes in your dependency graph. It has basically everything you're providing as a dependency, and you have your component, and that defines where it gets injected into, as well as sort of how all the connections happen. Question up the back?
Yes, is there any way you make the font bigger?
Oh, yeah, sorry. Yep, I'll get into that in a second. I'll just zoom in so it's a bit easier to use. So probably when you start off, you'd start off by defining a module, which you just have as a plain Java class. You annotate it with the @module annotation. This is provided by Dagger, and every single thing which you provide, you have a method for it, which does the actual providing, and then you annotate it with the provides annotation, and that gives you the value. You can actually define scopes for it, so you can do singletons for it if you'd like, as well as if you're providing multiple values, there has to be a way of sort of resolving the difference between the two. So there is this sort of named annotation which you can use, and I'll go more into that. And then you have a component right here. So it requires a scope if your module has a scope, or some provides have a scope with it also. It's an interface, and this actually gets generated for you by Dagger when you use it, and you just have all the stuff in there. And this is what I mean by strongly typed. It only works with specific classes, so if you can't really do interfaces with it. You need strongly typed classes. You just define a couple methods that say inject, and use this sort of say where it's going into. In your sort of target class for your injection, I'm just going to show you my injected into class. It's got the dependencies, my injected into object 1 and 2, and the inject annotation. And if you need to resolve any like conflicts because you've got two separate objects, you have the named annotation which you also plug there. This is actually a inject method. I usually leave these as protected or package private, so you can modify these in tests for testing purposes, which I'll get into later. You just set it up with what gets generated by Dagger, which is my Dagger component. You set up a builder, you define and inject your module into it, you build it, and then basically you do the injection for it. Now time to break stuff. Probably first thing which I'll go into is leaving out the named annotation. No, actually, let's leave out a provides annotation. So if I run a build on this, and a required, this will work, and something which is a dependency for something else is not there, you get a build failure, and you get a somewhat informative message down the bottom, and it tries to guide you to where you've gone wrong. This is the sort of ambiguous version, so if you have the ambiguous ones, if you hit build, not that, hit build, it's going to go, which one of these two things are you providing? And the same applies for where your target class is. And you get a similar sort of error. And if you look, you kind of have to scroll down to see what the error is, but it's there and it sort of points out where it's going wrong. And just to prove that it sort of works, just rebuild it. And there's a test in there, but I'm not going to go into that. It's sort of very easy for a test. But that's sort of the anatomy. That's how you can break stuff and protect yourself from various things. Dagger will help you out a lot. Now into the sort of now to the sort of very quickly put together application. This is sort of your typical application structure with Android. You have an application which has basically the function of providing an providing a meetup raffle, essentially. So as part of the application, you would normally do something like, let's see, setting up your application, and you have a retrofit adapter, for example. So I'm actually using retrofit as my network stack, so I can do calls to the Meetup API. So I don't want to keep recreating it. So I have my Dagger package there. And if we have a look at the sort of applications setup, it has a bunch of dependencies which it needs to set up things. So this is actually what's used. It's a singleton. It's used throughout the app. There's a couple screens in there, and I'll show you what happens in there. It has a dependency on a retrofit builder, which is provided here. And you can have dependencies of dependencies, which is what's going on here. Retrofit builder has a JSON converter example, as well as a meetup configuration dependency, as well as a OKHTTP client dependency. So these are all just network stacky stuff. It's only going to be created once, and it's going to be used by the application. And just here, I've got some logging, just so you can see in the logs that it's only being created once if it's a singleton. Probably just fire up the app really quickly. I hope you can all see that. Because it is zero error handling, if it bugs up on me, don't blame me. I'm just going to blame it on network. You have a simple thing. It's been hard-coded right now to use my Meetup API key, as well as grab MelbJVM's latest upcoming events. So if you just pick one, and it gives you the list of RSVPs who've responded yes, and you hit pick winner, and it'll pick a winner. This isn't official, but we'll do that at a late point in the night. So that's sort of how it works. You just have essentially two fragments, which I'm not going to go too into because it's kind of 2 hours worth of work. It just has all the dependency injection here. Fragments have a presenter, which has its own dependencies, a bit of view binding just for UI interaction that uses button knife. It's not going to go too into that. And it just basically makes a network call, presents the results from the presenter, and sort of deals with that. And as you can see, you can pick a random winner. And I promised I haven't rigged it in any way. Actually, one more thing while I'm at it. Because I'm in a IntelliJ IDE, they do actually have code generation, the ability to inspect generated code. So this is super useful. Because Dagger is traceable and debuggable, you can actually step through the file, and this is what Dagger spits out, and this is the actual generated code for the actual injection. So it's quite a lot there. I'm not going to go into it. All you need to do is, as long as you've set it up, it's going to work. You should be fine.
So what does setting that up involve?
Oh, yeah. So other than adding the Gradle plugins, you set up your components and your modules. Like I sort of showed in the first example, you provide all your dependencies. And yep, that's right. So you have these, I've only got 3 for each, like 1 for each fragment. So it's really basic right now. One really cool thing which I've got is a sort of, you can have components that depend on other components. So we've got the application-wide component, which provides a retrofit adapter and all the dependencies for that, as well as the meetup configuration. But in the event list, it's actually has a dependency on the whole applications thing, so you can have it. One sort of cool thing is that because you have sort of user-defined scoped annotations, you actually manage and handle all the scoping yourself. So in the other example, I was just doing something simple like my component, build a new module, build, then inject. Here, because it is a self-managed scope, essentially, in the application, I just have a get instance method, which gives you a static instance of the application and provides component. So if you use a new component in your injection, you're going to get a new version instead of retaining any scoping. So it's one of the pitfalls you've got to look for. I have done it a couple times where I've accidentally created new components and buggered up code, but quickly fixed it, of course. Yep. And I did mention that it was testable. Normally you'd do this in the scope of an Android thing for maybe something like a presenter. This is a very basic one, but this is sort of based on what you do if you do like a sort of Makito test. So you've got your mocked modules. So instead of actually creating a live one, there's a couple approaches to it. So you can actually mock a module. You can mock whatever you're going to actually inject. You can have what you're going to test. So in your setup method, you just initialize your mocks. For your module, because it's initialized as mock, you just replace what it provides. Run the builder on the actual tested object, and you can just keep going and writing away at tests. And there's a couple other examples for different approaches to writing tests if you want. Couple things which I haven't covered, but you can check out online. Bit of let me Google that for you, and some bonus stuff. There is lazy injection, so whenever you say my lazy object.get, then it actually does the injection at that point of time. And there is actually providers and factories. So if you want multiple instances of the same type of object, you can do that. There's a difference, and there's actually some links in the speaks notes and some more information about scoping, annotations, and that sort of thing, and some links. So feel free to check it out. If you're an Android developer, playing around with Android, or even if you're Java, it's a really good framework to use. And for the last 6 months, I've been stuck with it. So yeah. I have a bonus slide for those who, for anyone who wants to have a look at it, but I'm not going to go into it. So I think that's sort of my lightning quick introduction to Dagger. Any questions?
I was interested about you using this because of the performance, because it's one area that JVM I'm interested in. Have you ever found situations where it hasn't performed very well, and how would you go about profiling it, or how it behaves with, say, the garbage collection mechanism?
I might have to admit this, we haven't actually had to deal with performance as much. We have performance issues, but that's mainly around network time. Because it is generated code, essentially instead of doing reflection, which is really, it's kind of problematic on Android, you are using generated code, so it literally has no performance overhead because it's just like writing code yourself, essentially. But with Android projects, you can actually run Profiler in Android Studio, and you can check out what's taking a lot of CPU time. If you've got a very complicated dependency graph, you can actually analyze that and see which method calls are happening. And it just depends on your IDE and where you're using it. But especially in an Android context, you have some tools in Android Studio that really help you out. Any other questions, I guess?
Does Dagger work alongside Android annotations?
I haven't tried it, but I think it would. I think it would, actually, because Android annotations, yeah, it does generate some code itself, but so does Dagger. And I suppose as long as you're using the right generated code in the right places, it should work fine. But yeah, there are alternatives to Android annotations, and what I've found is, especially when you're dealing with the generated class for Android annotations, you have these underscore prefixes at the end of the class names, which I find are just kind of ugly and hard to understand, and there are alternative libraries to do what essentially Android annotations does. Yeah. I think there's one more.
In terms of the automated builds and testing processes you go through, is it straightforward to include those Dagger tests as part of your test suite, as part of your build?
Yeah, essentially you just write it as unit tests. One thing to remember is your modules are essentially just code. So you can have some complexity in your modules if you want to. So if you provide a value into it, that's very conditional. So if something's true, then do this. If something's false, then return something else in a provide method. You can unit test the heck out of that. It's all just freely available for you, and it's very testable. So what we've found is that, especially with what we do with presenters, which is a layer on top of our fragments in our apps, we actually mock out what the actual module provides, which I've shown you in that approach. But also we've had some cases where we've had to do conditional providing, and we have written unit tests for that, and it works fine. Yeah. Anything else? I suppose that's it.